So everyone, good evening, or good morning, good afternoon if you're attending outside of Chicago or wherever you are attending. Thank you very much for coming to this webinar between ACM Chicago, Mid-America IT Connect Club, as well as IEEE Computer Society Chicago. So my name is Alvin Chin, and I am the chair of ACM Chicago and IEEE Computer Society Chicago. And for our April webinar, we have Melissa Roemmele that will be talking about AI augmented creative writing. So IEEE Computer Society Chicago, so we've been having joint events with them pretty much since the pandemic started or so. So it's the Chicago chapter of the IEEE Computer Society. So IEEE is kind of like the sister society or so of ACM. And so we hold meetings on software, hardware, computing, AI, big data, similar to what ACM Chicago does. So like I said, I'm the chair, and we have our web and our social media pages. So these slides will also be sent to you afterwards as well. So you can also follow us on our social media sites. We also have our YouTube channel as well. So you can also look at previous YouTube webinars that we have. And if you want to become an IEEE Computer Society member, you can go to that link to join. There's lots of really, really interesting stuff that Computer Society does. A lot of webinars, a lot of personal improvement, career, conference papers, things like that. So it's really good. And of course, welcome to the members of the Mid-America Club IT Connect group. You know, if we would have this in person, you know, we've had our talks at the Mid-America Club. So if you know the Aon building, which is on East Randolph, the 80th floor of that building is Mid-America Club. So it's a private business and social club, and it has 360-degree panoramic views of the Chicago skyline. So we've had our meetings now for, I think, for the past 4 years or so. And so we also do with topics like cybersecurity, connected autonomous vehicles, big data, cloud computing. The chair is VJ, who is one of the panelists there that you see here. So he's the chair, and I'm the vice chair. And we have our web, Facebook, and Instagram if you want to know more about what the club does. And then, of course, ACM Chicago, our host. So ACM is the Association for Computing Machinery, for those people that do not know about it. So it's a professional computing organization. So we hold monthly meetings. Normally, if we were doing this in person, we would have held it in the Loyola University, the Water Tower campus in downtown. Of course, we've also held it in Mid-America Club as well, and also the Loyola campus in Evanston too as well. So like I said earlier, I'm the chair. Our vice chair is Mark Temkin, which you see in the panelist grid there, and our treasurer is Greg Newmark. So we have our web, our meetup site. So probably for a lot of you, you know about this webinar from our meetup site, and of course we also have our Facebook, Twitter, LinkedIn, YouTube, and if you want to become an ACM member, then you can also go to our web page there. Okay, so the reason why you're all here this evening is, of course, for our featured presentation. So I will now hand it over to Mark, our vice chair, to introduce our speaker for this evening. So Mark. Thanks for coming here tonight, and short introduction. So live from very close to Hollywood, California, let's welcome our speaker, Melissa Roemmele, who will help us explore the convergence of natural language and creative writing.
I'm going to be talking about AI and creative writing, or how computers can help people write fiction. So I'm currently at RWS Research, formerly SDL. SDL got acquired about 6 months ago by RWS. So first I want to start with giving just some broad research context related to the topic of this talk. I might use certain terms, and I want it to be clear what I mean by those particular terms. So Obviously, this talk falls under the very broad umbrella of artificial intelligence, or computers that model human behavior. That's one way to think about AI. I'll also be making reference to the term machine learning, which is a particular technique in AI. And then within AI, there's work on computers that model human creativity, and the most common term associated with this research is computational creativity. And then there's a lot of work on computers that model human language. And this most often goes by the term natural language processing, or NLP. And what I'll be talking about today is at the intersection between these two things. It's often associated with the terms creative language generation or story generation. Those are prominent terms used in the research literature associated with what I'll be talking about. So first, since I mentioned this falls under the category of creative language generation, I just want to briefly mention some of the work that has gone on in this space, just to give you a sense of where we're at with this research topic. So there's a lot of work on generating different types of creative language automatically. One is poetry, so one of the most prominent forms of creative writing that people engage in. Related to that, song lyrics, another effort for automated generation. Slogans, so language that's associated with marketing or advertising campaigns. Word blends, when you have two different words, you combine the sound of those words to come up with a new word that's related in meaning to both of them. So now, related to humor generation, which, humor is a huge instance of a huge endeavor in creativity. There's work on pun generation. Also trying to generate satire. And now getting a little closer to the topic of this particular talk, story generation. So one configuration of story generation that's well represented in NLP literature is trying to generate short stories or flash fiction. So these could be stories that are composed of a few paragraphs or even a few sentences. So an example, you have some sort of writing prompt that conveys what the topic of a story should be, and then the goal is to generate something that addresses that prompt or story premise. I'm going to be talking about a slightly different configuration of story generation, and this was the focus of my thesis work, and it's called narrative continuation or story continuation. So in this setup, you have some sort of initial story that is human authored, and the task of the AI system is to generate a continuation of that story, or, for example, the next sentence that follows the given story. My thesis work looked at this in the context of an interactive application where users could start writing a story, and then they could prompt the system for so-called help in generating a suggestion for what could appear next in the story. And then they could do whatever they wanted with that suggestion in the interface. So because this has been the focus of my particular research, what I'm going to be talking about today, I'm illustrating a paradigm that focuses on this story continuation task. But I want to be clear that the paradigm that I'll be discussing can generalize to other types of creative language. So there's obviously a lot of discussion about the future role of AI in our lives. And when we're talking about this with specific reference to human creativity, there has definitely been a conversation that's focused on fear, where the assumption is that, along with AI automating a bunch of jobs, it's also going to automate the creative writing endeavors so that creative writers or even artists in general will be out of a job. So we see, reflected in these headlines, we see that idea that humans and computers are in competition with one another when it comes to creative endeavors. But I think a lot of this discussion does overlook another important question that might not be as obvious to people, and that's, can computers aid human creativity? So rather than computers and humans competing with one another, can their interaction actually yield something that is more creative? And there are artists that have identified this opportunity. And these are the artists are obviously the people you would expect to have the most fear of AI systems. But not everyone sees it that way. And there are actually people who are excited about the role of AI in them pursuing their own creative endeavors. So for example, this quote from Bernard Lubat, who has interacted with a music generation system called Continuator. He says, "The system shows me ideas I could have developed, but that would have taken me years to actually develop, yet everything it plays is unquestionably me." So he's highlighting that his interaction with the AI system has made it easier for him to be creative in writing music, and it also hasn't taken away any of the ownership over the ultimate composition. And Harold Cohen, he is a painter and also a programmer of a painting generation system called Aaron. This image is actually an example of the generated output of that system. He says, "In our version of an AI-enhanced future, our software might force us to think more rather than less." So this is really counter to the idea that with automating creative endeavors, none of us are ever going to pursue anything creative. We're just going to rely on machines for that. But he's saying the exact opposite, where we're actually going to challenge ourselves even more in being more creative as a result of our interaction with these systems. So now I want to talk about some of the theoretical basis for computational creativity. And this is some general principles, not just those specific to creative writing, but to creative endeavors in general. Margaret Bowden is a really important AI theoretician in this area. She published a book called The Creative Mind, where she lays out a lot of principles focused on the interaction between computers and human creativity in the future. She specifically identifies that one prominent type of creativity is what can be called combinatorial creativity, and it involves unfamiliar combinations of familiar ideas. This notion is particularly relevant to linguistic creativity because you can see linguistic creativity as unfamiliar combinations of familiar linguistic units. So a linguistic unit could be a word, for example. And this process involves some degree of randomness and unpredictability. These are terms that people typically don't associate with the creative process, but she identifies they actually do have an important role in yielding creative output. And part of it is this loosening of conventional constraints in our minds that enables novel connections. And this is an inherently unpredictable process, this process of discovering novel combinations. She uses the term serendipity in reference to this because by chance, some novel connection that we discover may be surprisingly meaningful. So in the brainstorming process, we're putting a lot of different ideas together. Some of them might not necessarily be meaningful or valuable, but serendipitously, some actually might yield something that's really insightful. So now that I've given some of the foundation for computational creativity in general, I want to specifically now talk about story generation as it relates to AI systems that try to generate stories. So stories and definitely other types of creative language as well, and language in general, are produced and interpreted according to common sense. There's different ways common sense can be defined in the context of AI, but you can just think about it as our intuitive expectations as human beings about how the world works. Computers really struggle with common sense, and this is the key challenging in developing AI systems, particularly developing AI systems that can tell stories. So to give you an example, let's say you have some sentence, "The child let go of the balloon." when we read this and we read the event conveyed by this sentence, we have a bunch of different ideas about perhaps what's most likely to happen next in response to this event. So one thing that comes to my mind, and probably comes to your mind as well as a possible next event, is that the balloon flew away. And in addition, when we're just constantly making predictions based on what we see, based on what we read, we can also then predict that as a result of the balloon flying away, the child started to cry. And just in reading this, we're bringing all sorts of common sense knowledge into the equation here that enables us to make these predictions about what's most likely to happen. So for example, we know that balloons that are filled with helium are going to rise, and that's why the balloon flies away in reaction to the child letting go of it. We can also imagine that the child started to cry because they're attached to the balloon and losing it makes them sad, and crying is caused by sadness. So there's all sorts of common sense interpretations that we're making here that make it very easy for us to understand what's going on in this piece of text. And this is essential to our understanding and also production of stories. So when we're thinking about the role specifically of human creativity, not just common sense interpretations of stories, well, skilled fiction writing, it defies our expectations of what happens next. The prediction of what happens next that I just talked about, skilled fiction writers are really good at defying those expectations, but they also do so in a way that there's still a clear interpretation of the events. So as a reader, we read a story, something might happen, it initially doesn't really make sense, and then you read more in the story and you're like, oh, okay, I see what's going on here. This is hard for most people when writing, though. Most of us are not professional fiction writers, and we find it easy to bring to mind what's most obvious to happen next in a scenario, but it's harder for us to break free of those common sense expectations and write something that's less expected or surprising. So in relation to this, I now want to talk about AI models as they pertain to story generation and how these can be used as tools to support creativity. So this is a very, very broad scheme here of a machine learning model. I use that term machine learning at the very beginning of the talk, referencing that it's a popular technique in AI, and particularly a popular technique in language generation in general now. So the way it works at a very, very high level is you have some sort of linguistic input. You have an encoding of that input that is all numerical. And then your output, which is what you're generating, is what it results from the encoding of the input. So for example, here, under the hood, everything is represented numerically. Both your input and the encoding of the input. That's kind of, you can think about that encoding as the meaning of the input, whether it's a word or a sentence or a story segment. And then what you're ultimately doing is producing a probability distribution based on that encoding. And so you have these probability distribution could be over words as well, or sentences. And it's such that because it's probabilistic or statistical in nature, there's always a certain likelihood assigned to different outcomes or different linguistic units. So some are more likely than others. So to make this more concrete, here's that same model applied to the task of story continuation, or one way that it can work in this context. So you have your current story, you encode that in your model, and then that enables you to make a prediction for the continuation, or in particular, the next sentence in the story. And when you're using a standard machine learning approach to try to do this prediction task, what generally happens is that the model is going to read a bunch of stories, and that's what enables it to learn probabilities of story text that inform the continuations. The story text or the continuations are predicted according to these learned probabilities. And the process of learning, or we call model training, involves a constant feedback loop where this story encoding, this sequence of numbers that represents the meaning of the story, is constantly adjusted in order to make better predictions. And here, better predictions means segments that are actually found in a human authored story. So we want our model to predict things that look like they would appear in some story that a person would tell. So for example, using the same sentence that I showed on the previous slide, let's say your input is the child let go of the balloon. The task here is to predict the next sentence that appears after that one. So you encode that into your model. It's all just a huge vector of numbers. And then that numerical encoding enables you to make a prediction for the next sentence. When the model first starts learning or first starts training, these predictions aren't going to be very good. They won't look like things that actually appear in human authored stories. But every time the model sees a story, it's getting some feedback about what it actually should predict. So the model's being told, this is what you predicted, but I wanted you to predict this, which actually appears in the story. And then it updates its encoding to then make that prediction better. So over time, it's just getting this feedback constantly with every single story it sees until it reaches a point where the encoding is so-called good enough to enable it to predict something that appears in a human authored story. So then when you go to generate story text, or in this context, continuations, using a model that has already learned probabilities of story segments, the common way to do this is to iteratively sample words according to the learned probability distribution. And because there are so many probable combinations of linguistic units, in this case, we'll look at using words, the generated text is often unpredictable and novel. So it often looks like something that might be close to what you've seen in a human authored story, but it's highly likely to be something that's not just directly pulled from a human authored story. To make this more clear, here's an example of how this sampling would work. So we have our same sentence again, the child let go of the balloon. We're trying to make a prediction for what happens next. We've already generated the word the as the first word of the next sentence, but now we want to pick what's the second word here. Well, we have a high probability assigned to the word balloon because we've seen it a lot in our human authored stories that the model observed. We also have a high probability assigned to things like child. This is probably something that the model has encountered before. But then there's also smaller probabilities assigned to a lot of other different words. And these are things that maybe in some stories occurred, or the model has seen it in a similar context to this input sentence. Because it's all probabilistic, there's always going to be small amounts of the probability distribution that are devoted to things that maybe are not extremely common in this particular context. But because there are so many probable combinations of words and you're doing this sampling iteratively where you pick a word, recompute the probability distribution for the following word, and then pick again and do this again and again, you end up with many, many different combinations of things that could possibly get generated after this first sentence. And that's why the text often is very novel and not something that's directly found in a human authored story. So now thinking about storytelling and creative storytelling according to some continuum here. In one direction, you have stories that are highly conventional. So this is associated with our expectations of what's most obviously likely to happen next in a story. When you push that to an extremely conventional story, you get something that would be perceived as predictable or boring. And this is also something that is really easy for humans, as we just discussed. We're very, very easily able to bring to mind the most obvious thing that could occur in a particular scenario based on the information that we're given. So, for example, same sentence here, the child let go of the balloon flew away. This would be an example of something that's very predictable. And if we encountered it in a story we might not consider the story all that interesting. It's like, okay, duh, I knew that was likely to happen. If you go in the opposite direction, in the direction of novelty, and I mentioned that with the tools that we're using in AI, it's very easy for these systems to generate highly novel language. That extreme can often give you something that's perceived as nonsensical or meaningless. Oops, sorry. So an example is, the wind rushed up its long straw fur to a light blue. This was actually something that I observed, the model that I just showed you, I observed that it generated this. And this is, like I said, definitely novel. It's also, in the context of a story, pretty hard to understand what it means. There might be certain creative writing scenarios where this is something that is considered cool or valuable, but when you're telling a story and you want the story to be interpretable, this might not necessarily drive the story forward. It's just too novel to the degree of being uninterpretable. What we're actually striving for with both human storytelling and then also with computational systems that tell stories, something that is surprising and intriguing, but also interpretable. So an example here might be the balloon burst into flames. This doesn't immediately make sense based on just the childlike of the balloon. We don't really have enough information to make this interpretable. But the idea is that if you saw this in some story, it might intrigue you to learn more and to read more in order to find out how this actually came about. So what I'm describing here is that there is a complementary relationship between humans and machines, in that people are already really good at predicting what's most likely to appear in a story because we have such strong common sense expectations. But writing surprising stories is a process of expanding beyond what's most likely. And for most of us, that's a pretty difficult thing to do. So the question here is, can we take advantage of the unpredictability of AI systems to then give people new ideas that they might not have considered because they're so constrained by common sense expectations? So with this paradigm that I'm proposing for AI augmented creative writing, AI systems don't necessarily need to simulate human writing in order to be valuable in giving people ideas for what to write about. It's simply that their output needs to yield interpretable ideas. So they have to have some level of common sense reasoning that makes their output valuable to people because they can figure out what it actually means. But the output itself doesn't need to stand alone. It can be an interactive thing where the human then crafts what the meaning of the output, puts it into their own words, and it's just a tool for brainstorming. And yeah, so a tool for brainstorming in that it promotes combinatorial creativity. So that was the term I used for putting together unfamiliar combinations of familiar ideas. In this paradigm, then the AI is responsible for establishing novel connections, and the human writer judges their value. So there might be a lot of different novel things that an AI system produces for a story, and a lot of them might, you might decide are just not very meaningful. They're nonsensical. It just doesn't fit. But some of them actually might turn out to be valuable, and this does mimic the process of human brainstorming when it comes to writing stories. So going back to that term serendipity, because this creates opportunity for serendipity or coming across things that are surprisingly meaningful, maybe AI can be the thing that enhances that serendipity or creates additional opportunities for it. So let me give an example of how this paradigm could actually work in an interactive application. Here, this is my real interaction with a particular language generation system that's called GPT-2. GPT-2 has gotten a lot of attention recently because people have been really impressed with the output that it gives. It is it has the same overall architecture as what I just described with the machine learning model. It just has specific details, and it is trained on a lot of stories, and it has a lot of parameters. So it's a really, really massive memory intensive model. So going back to this example, the child let go of the balloon, maybe if I'm writing a story, I might, the best I might come up with is the balloon flew away. This is reasonable, but maybe there's other possibilities that I want to consider that could take the story in an interesting direction. So these are all real examples that when I gave the GPT-2 model this text, the child let go of the balloon, and asked it for a continuation, this is what it gave me. So I'm just going to highlight some examples that I found particularly interesting. So one is, he saw the white and green colors of the balloon, the color of the sky, and he was happy. So in the original example that I had showed regarding the story where the balloon flew away and then the child was sad, that's naturally where my mind went. But here, this is something different where, the child somehow has peace with the balloon flying away, and it, he ends up being happy for whatever reason. Alternatively, this was something also interesting that the system generated that is a little bit awkward, but it was still attached to his head, but he was already floating. So the language is a little odd, but I interpreted this to mean, even though the child let go of the balloon, it was somehow still attached to his body, and now the child is floating away. The balloon flew over the head of a neighbor who grabbed it. So this is really an elaboration on the balloon flying away, but it adds the specific detail that a neighbor intervened in this, and maybe we can imagine that the neighbor is really mean, and then there's a worry that they won't give the balloon back to the child. So there could be that emotional dimension to it. One that was particularly surprising to me was, "I'll always have you," the balloon said, "I'm your friend." And now all of a sudden, the balloon is an animate character in this story. We can see that this, there are certain contexts where this story would have been told. There are many, children's movies where inanimate objects do become characters. Definitely not something that I would have considered. And the balloon burst, sending a huge shockwave of wind and sand up into the sky. Definitely something that defies our notion of common sense physics here. The child's face became red and puffy, so maybe the child was allergic to the balloon, and that could definitely create some conflict in this scenario. "It's not good for me," she said. So this is a little bit vague, but one thing that came to mind when I saw this was that maybe the balloon is some sort of crutch for the child, or the equivalent of a stuffed animal, and the child is trying to move beyond that and enter a new stage of life. So they're willingly giving up the balloon. And then finally, another example I found really interesting was, "It was a perfect moment, but of course there was no balloon." And this suggests to me that there could be some sort of unreliable narrator thing happening where the balloon was actually a figment of the child's imagination, and that could lead to an interesting story. So I just show you all of these examples because these were things that I hadn't necessarily considered when I tried this contrived exercise of writing a story that started with the child let go of the balloon. Maybe these aren't things that you would necessarily want to just take directly and put into your story, but it's an idea generation process. So the value comes out of the interaction here with me then bringing some interpretation to these segments and figuring out where I want the story to go in response to them. So there was this interesting article that came out. Sigal Samuel wrote this about her interaction with GPT-2, the same model that generated those examples. And she's a professional fiction writer, so a very different perspective than I have, not a fiction writer. She wrote, one thing that was particularly interesting is that AI can be an incredible tool for writers precisely because it's great at defamiliarizing our world. And by defamiliarizing, she means presenting ordinary things in non-ordinary language. And she says the humanish language it generates can startle us into seeing things anew. And this is interesting because, so I was talking about with the examples I showed before that they yield ideas, but maybe you don't necessarily want to use the language that's given, you want to reinterpret it or rewrite it. But here she's actually pointing out that the language itself is interesting, But it's interesting because it doesn't sound fully human authored. It's defamiliarized. And that apparently to her has some value for writing stories. She also mentioned, consistent with what I was trying to motivate before, she said, it came up with an idea that I honestly wish I'd come up with myself. And then finally, she says, I wouldn't want to simply copy paste sentences written by the model into a novel. The generated text often doesn't serve the story or belong in any way. So there's this defamiliarized language, and maybe some of it is valuable, but what she's saying is just as a whole, I'm not just going to take these sentences, put them into the story, and then run from there. And that's, again, we can imagine that AI systems don't necessarily need to do this, okay, here, copy paste, here's something that you can copy paste into your story. The interaction doesn't necessarily have to go according to that in order for these systems to be valuable. Okay, so with the last few minutes, I want to talk about briefly the issue of evaluation of these systems. Or how do we know that AI is actually helping people? Well, we need to have some form of evaluation that gets incorporated into our research on these systems. So for a lot of language generation tasks, because they're imagined to operate autonomously and maybe not necessarily with human interaction or human intervention, they try to exactly simulate human writing. So the goal of these systems is to almost trick people into thinking that they are human. But this is a really different paradigm where here, as I mentioned before, good AI output is something that helps the author, and it might not necessarily need to sound human authored itself. So what this means is that we need unique evaluation paradigms in AI and in NLP that focus on the objectives of the human author. So this is something that I actually have worked on with my research. I won't get to talk about too much, but this involved in the interactive application that performs story continuation that I mentioned. We did work to track and predict what people would do with the output, so we could then figure out, well, what is actually helpful to them in terms of what the system is providing. And that's the type of a paradigm or type of evaluation methodology that I would like to see more of in the future. And so finally, there definitely are some ethical considerations to this work, just like there's ethical considerations to all AI systems, but particularly here, one thing we need to consider is that the language that the models give us could possibly amplify societal biases. And the reason they would do this is, of course, these models learn from human-authored stories. Humans are very biased. And when the model picks that up, they could end up perpetuating that bias in the language that they show to people. And this could be very dangerous because we do want to find a way to try to alter these biases in future generations. Also, for a lot of media, people have control over the content that they watch. So it's described to them upfront whether there could be things in, for example, a TV show or a book that could be triggering to them or upsetting to them. And then they can decide whether or not they want to view that or read that. Here with these systems, we haven't quite figured out a structure for ensuring that people are protected from things that they don't want to see. So that's absolutely something that we need to make progress on. And then there's also the question of who owns the outcome of interaction with these writing systems. Well, one thing is that because, again, these models are trained on human-authored stories, you could accuse them of plagiarizing people because they're learning from those stories. They don't produce, they tend to not mimic exactly what they've seen in those stories. So maybe it's not direct plagiarism, but there still is an issue of do those authors of the stories that the model's learning from, do they have any ownership over the content that the AI systems produce? And then also when these AI systems are deployed, who owns the outcome in terms of the division between the person who's interacting with the system and then the AI system itself? Does the system itself, because it's providing language that someone might end up using in their writing, does it have its own ownership over the final writing? That's just an open question here. So that is it, and I'm happy to discuss or answer any questions now. Thank you.
We have a number of questions. So from Joel Mussman, many stories have a direction or outcomes that need to be met. How hard is it to incorporate this into your model? Have you thought about this and tried it?
So that's the core problem here, and what I'm suggesting about how this paradigm of interaction is useful, because you could see from those examples, all the different things that it generated were very different and could serve, different objectives. And you don't necessarily have full control over what it's giving you. I'm arguing that that's actually an advantage, because it's this process of serendipity where you're exploring all these different novel connections that the system has made, in this case, all the different possible ways the story could go. And then you, as the person who owns the final output of the writing, decides what's a valuable way that the story could go. And then obviously there is a lot of work on trying to make these models more controllable up front. So let's say you do decide, okay, there's certain output I just don't even want to bother with. I already know up front that this isn't going to help me. And that's definitely ongoing research, trying to anticipate people's interests. Trying to anticipate people's interests up front in filtering the output that they see. But I try to, with this work, especially where we're at right now, I think it's important to not make too many assumptions about what people want out of these systems until we've rigorously evaluated them. We, as AI, designers of these systems, or AI and NLP researchers, we do impose our own assumptions. And I'm definitely not saying that I don't do that as well, because I'm thinking about this from the perspective of, well, what would I want out of a storytelling system? But we haven't even really reached the point in the research where we figured out, what do people actually want from their interaction with these systems? So, a lot of this stuff I'm proposing is theoretical, but I think, it's important to not decide for anyone up front that this is the type of story that they necessarily want to tell. We need to actually sit down and evaluate that.
Next question is from Sharad Hanover. What is the underlying technology? Is it a recurrent neural network? Is it a short-term memory, or is it deep learning?
Yep. So I didn't discuss that, but yes, I use the term machine learning very, very broadly. But in my work, for story continuation, I used a recurrent neural network. The GPT-2 model is a transformer language model, which, there's similarities there. It's just slightly different architectures in how they make their predictions.
This is from Tim Yao. In terms of idea generation, have you considered using this approach to generate plot outlines, a higher level summary, rather than writing the final prose, perhaps in an early phase of ideation? In other words, with the snowflake method.
Yeah, so this is not something I have tried in my research, but this is absolutely something you could do. I was showing all examples that were written in natural language, and the models I was showing were predicting words, but those same models could take any type of linguistic inputs. So you could, if you had some sort of way of representing plot, which there is a lot of research on trying to come up with formal representations of plot, those could be used as input to your system. It doesn't have to be words or any other sort of natural language.
Okay, and from Max Za, for industrial NLP practitioners working on producing models that recommend rules-based language, such as contracts and agreements, they're almost mechanical anyway. What are some pitfalls to look out for?
Yeah, so it all depends on the type of language that you want to generate. So there was a mention of contracts or highly constrained language where, that's a very different task from fiction generation where, maybe having output that sounds mechanical is actually the desired goal. Here, so there is a lot of, historically, rule-based systems were the dominant form technology and story generation, but recently people have moved away from that because there's this interest in generating more open-ended language that's not as constrained. And probabilistic models or machine learning models tend to serve that goal better. But I would say that the technique that you use is really dependent on what your actual goal is. What is the language or what is the content that you want to generate? And you would pick a technique that maybe a rule-based system does serve that goal more than something probabilistic where you have you're relying on statistics, which may not give you total control over the output in the way that you would want if it's something that does need to be highly constrained, like a contract.
Does the model try to stay within the vocabulary that the person has been writing in the first place, or does it start using words and terms or styles that are foreign to that?
So it's all dependent on what the model is trained on, what text it's observed. So in the case of GPT-2, that's this massive model. I said it's trained on a bunch of text. It's not just stories that it's trained on, it's also trained on Wikipedia text as well. So its output it's representing a lot of different language styles because it's just a lot of different people have contributed to its training data. But there is a lot of effort to try to generate text that is specific to some style, and it could be specific to the style of a particular writer. And there's different ways to go about that. One thing is that we could have models that are trained on a specific set of texts that are produced by a writer, or a set of texts that are specific to a given genre. And then you can tune these models to specifically try to generate language that fits within that domain or that is written by that particular author. That's definitely something that I was interested in with my thesis work. I didn't get to the point of trying to do that sort of personalization or customization and adapting the model to different types of genres or different types of writers, but it's extremely interesting.
Okay, and a question from Roxana. Good writers want help with various aspects of language, a particular figure of speech, etc. How can GPT-2, a language generation model, help with this?
Yeah, so that's the thing. GPT-2 is not trained with any sort of objective in mind with, hey, give me this type of interesting linguistic construction. It kind of just comes up with that by chance, like all of what I was talking about with this process of serendipity, where it might put together words that by chance are extremely interesting and meaningful and also novel, but it's not really, it doesn't really have that, it doesn't set out for that purpose. That just kind of happens through this serendipitous process. And Segal Samuel said, this was something that she, as a fiction writer, she encountered a lot in her interaction with GPT-2. I mean, there wasn't anything in particular that she did to tell the model, hey, give me this type of language. This is what I find valuable in this interaction. And it was a very open-ended interaction where there was no specific goal other than her just kind of exploring the system. But we can, have models that target different aspects of the storytelling process. Let's say, maybe you don't need help with writing a plot. You already feel like you're really good at that, but you do want to figure out new ways to express events in that plot, or unique language that could describe that. Maybe you're specifically interested in metaphorical language. It could be the type of thing where we then have a fine-tuned version of GPT-2 that specifically focuses on that objective.
Okay, Alvin has a question.
Mm-hmm.
Yeah, so Melissa, just was curious to know, what do you think about AI to help to write, stories in newspapers? And the reason why I'm saying about this is that because I saw actually in the Chicago Star Media kind of newspaper or so that they do have an actual GPT-3 that is actually generating just like a very simple article, and they actually show that, in the newspaper. So what are your thoughts about that?
Yeah, it's really cool. And I haven't seen that in particular, but I have seen attempts to get GPT-3, so the later version of GPT-2, to generate news. I think there's a lot of, a lot of people have kind of been concerned about this type of thing because of its potential to generate fake news. So, and that's reasonable because GPT-2 or GPT-3 doesn't have any sense of facts that it needs to respect. It's just because it's a stochastic model, it's just putting words together in a way that's interesting and sounds very plausible, but it doesn't have any formal sense of knowledge or facts that are true or false. So I think it's really cool from a creativity perspective, from the perspective of the topic I'm discussing, that it can generate those types of news articles. But I think we have to see them more as an instance of fiction more than anything. And there is a danger, as some people are concerned, in people using that model to generate things that are then presented as factual or as actual news. So more than anything, I think about the ethical considerations in something like that. And I don't have an answer as to, what we're supposed to do to protect against that. But that's definitely something for a long discussion as well.
Okay, and Greg, for the final word.
Okay. I was doing a little Googling, but I couldn't quite figure it out. Speaking of GPT-2 specifically, is that something somebody can play around with on their home computer, or do you need to rent space in the cloud to get enough power to make it work?
No, there is a demo, and I have a link to the article about GPT-2. I will update it to also include, there's an online demo that, so OpenAI is the organization that initially released GPT-2. And then there's another organization called Hugging Face that they re-implemented it or incorporated their OpenAI's implementation. And then they have just a online demo where anyone can interact with it. So I will make sure to include the link in the slides, and then anyone can try it out for themselves.
Thank you. I guess the follow-up question is that for your research, were you running it locally, or did you have a more capable method, and what did that look like?
Yeah, so when I did this research at USC with my advisor, Andrew Gordon, we had our own GPU enhanced machine that we did all the model training on, and that's very computationally intensive. So it was just a regular Unix box, but it had a GPU card in it, which significantly sped up the computation involved in training the model. But in terms of deploying the model, so the interactive application that I described, and by the way, I should have said that there is a link to that application that I developed. This is separate from GPT-2. The work that I did is called Creative Help, and there is a link to that that's given in one of the slides. So for that, that's actually just deployed. It's online. You can also interact with it as well, and that's just deployed on a CPU instance. So there's no special software that you need to interact with that either.
Thank you.
All right, great. Thank you very much, Melissa, for the wonderful presentation. Before we end this evening, I just put up a poll there, so we would like you to vote. To complete that poll. And while you're doing that, I will go ahead, and we have our next presentation, which is on May the 19th. And we have Nate Nichols, who actually is here this evening from Narrative Science. So Nate, can you go ahead and explain what you're going to be talking about?
Yeah. Thanks, Alvin, and thanks a lot for the talk, Dr. Roemmele. My name is Nate Nichols. I'm chief scientist at a company called Narrative Science. I'm really frustrated with dashboards and BI dashboards in particular. We say we want our employees to be in the data and make data-driven decisions, and then the tools we give them are things that were built for analysts, right? And so it ends up being only 30% of the companies looking at dashboards. And so we wanted to build something that would serve the other 70 to 80% of the company. So we built this product called Lexio that uses natural language generation, a totally different way of doing it than the talk we just saw, which will be fun to talk about. We use natural language generation, automated data storytelling to analyze the data and just write up the situation. So business users don't have to click around or try to understand how to use these tools or interpret a bunch of charts and graphs. They just have to read is the idea. And so a month from now, I'll be talking about the problem we're trying to solve, how it works at a high level, and then some of the fun, kind of crunchier technical details about how stories actually come together.
Great, thank you, Nate. So the meetup event is already on there. So you see the URL there. So you can go ahead and start signing up for that. And of course, you know, we're always looking for future speakers. So if you have an interesting topic, you want to share what you're doing in your company or at school, please reach out to us. So you can contact Mark, our vice chair, or you can contact myself. All right, so yes, it's now 7:01. So thank you very much, everyone, for attending this evening. And like I said before in the beginning, the slides will be sent out. So you will receive an email that has the slides for this evening from Melissa, as well as the slides I've shown here right now, as well as the recording. And if any of you are requiring professional development hours, PDH, for your professional engineering license or so, we can provide also that too as well. So you can qualify for 1 hour of the PDH. All right then, so thank you, Melissa. Thank you everyone for attending this evening. Continue to stay healthy and safe, and we hope to see you on May the 19th with Nate Nichols. Thank you very much and have a good evening.